This video is on multiplying and dividing rational expressions. Recall that since rational expressions are basically fractions, the rules for multiplying and dividing fractions apply. To multiply rational expressions, multiply the numerators and then multiply the denominators. To divide rational expressions, multiply the first rational expression by the reciprocal of the second. And when you're doing this, you may want to actually factor the polynomials first. Then simply divide out any common factors. Let's take a look at several examples here. So my first example is x minus 3 over x squared plus x minus 2 times 4x minus 4 divided by x squared minus 9. So I think before I start doing any multiplying, I'm going to factor anything that I can. In fact, I'm seeing that 3 of those expressions can be factored. So here I have x plus 3, and then my first denominator can be factored into x plus 2 times x minus 1. And for my second rational expression, I can take out a greatest common factor of 4. And the denominator of that one is a difference of squares. Okay, so now if I were to I could just multiply across the top and bottom, but I do have some common factors. So for example, I have an x minus 1 in the numerator here and an x minus 1 in the denominator there. And I can cancel out these common factors of x plus 3. And that's going to leave me with 4 over x plus 2 times x minus 3. And you can actually leave it in factored form. I kind of like it like that. You see that there's nothing else that can be canceled out. Second example is 5x plus 10 over x squared divided by the binomial x plus 2. So basically, if I'm dividing by x plus 2, that's the same as multiplying by 1 over x plus 2. And I'm also noticing that I can take a greatest common factor of 5 out of the numerator here. And instead of dividing by this, I'm going to multiply by the reciprocal. And now I've turned this into a multiplication problem, and I have a common factor of x plus 2, and that leaves me with a 5 on top and an x squared in the denominator. And my last example is actually called a complex fraction. This is a rational expression that has a rational expression in the numerator and a rational expression in the denominator. Remember that this is just division, so this is going to be x minus 3 over x squared plus 3x plus 2 divided by x squared minus 9 over x plus 1. So I'm going to rewrite this as division. Actually, maybe I'll go ahead and factor this as well. So that's the numerator that I've written down here, and I'm going to, instead of dividing by this, I'm going to multiply by the reciprocal. So that means there will be an x plus 1 in the numerator, and then my denominator is x squared minus 9, which I will go ahead and factor. And now I can cancel out any common factors. An x minus 3 and an x plus 1. And be careful, it looks like there's nothing on top, but there is actually still a 1 on top. And I can write this as 1 over x plus 2 times x plus 3. So in this video, we took a look at how to multiply and divide rational expressions, very similar to multiplying and dividing fractions, where you multiply the numerators together, multiply the denominators together. Make sure that if you have any polynomials that can be factored, you do that and cancel out any common factors.